Okay, Jim, the camera's rolling. You're on.
All right. What we're going to do here is demonstrate some of the unusual properties of a great new product with a distinctive color. We've got the number 3 featured here because it plays a key part in our story. 3 times longer. As we say, unusual properties. Properties which have jaw-breaking names. Words like, for example. And yet, even if these things are difficult to pronounce, they aren't at all difficult to understand, and they'll be less difficult for you to explain to your customers because they can be demonstrated graphically and dramatically. Now let's see what's first on the agenda.
How about the mayonnaise, Jim? Fix us up with some mayonnaise?
You bet. And that's a good way to start. Remember what it was like back in Grandma's day, before supermarkets, when she used to make her own mayonnaise? Well, we're going to try the same thing right here. It's too bad we don't have a grandmother here to help us, but, well, we'll do the best.
Wait a minute, Jim. We were thinking about that earlier, and we went right out and asked a nice little old grandmother to come in and give you a hand. Would you come in, Granny?
Wait a minute. This is no grandmother.
Listen, Jim, you stick to your grandmother, and I'll stick to mine. Now, let's go ahead with the demonstration.
Well, all right. Nice having you here anyway, Granny. Now, one of the most dramatic improvements that... You see, surveys have indicated that 85% of all of our... and cold sludge wants to form, which can be murder on the... Now, I'd like the camera to focus on something I know you'll find of the greatest interest. No, I mean here, down on the table. There. Ever watch a woman make mayonnaise? She takes acid, she calls it vinegar, and she puts them all together in a bowl. Then she puts the bowl in ice to keep it cool. She picks up an egg beater, and she starts to go to work. And she produces a nice, tasty batch of mayonnaise. Well, what we're doing is a kind of kitchen chemistry. In this case, a shot of water, we could put in 2 shots of water, but this is more than enough for the purposes of the demonstration. Now, let's put in the acid. And let's put into the, which in this case is the sludge-making solids. The road and the tetraethyl lead decomposition products that accumulate. If this looks like a lot, it is a lot, because this is light, fluffy. Now, with the help of this kindly old soul on my left, we'll make some mayonnaise for you. You know, if this is a race, I think she's winning. Just to be fair, work around the edges. Yeah, she's better at this than I am, or I've got a lousy egg beater. And I wish I could tell you whose it is. Nothing like jet black mayonnaise for salad. Well, let's stop for a second and see what we've got. The real demonstration comes when you pour it out of these mixing bowls. Lets the light shine through. You can see that if you use, you just can't make mayonnaise. Now this is real cold mayonnaise. This is what fills up, that clogs the moving parts and makes them sluggish. This is what really steals power. Now without these power-robbing deposits, more economically, and consume less. And you realize the tremendous importance of this demonstration when you analyze the kind of driving most of us do. 25% of all the driving we do in this country consists of trips of less than 1.5 miles. In 65% of all of our driving, the trips are less than 6.5 miles. 85% of all our trips are less than 14 miles. And that 14 miles is the magic number, and that means cold sludge can form. Now, as on a long weekend drive, the water may dry out. What we have made is mayonnaise. If we eliminate or neutralize any one of these ingredients, we do not have mayonnaise, nor does it form with... You see, high-speed driving does not produce mayonnaise because the temperature of the engine is too high. The engine hasn't been invented, so we can't eliminate water. The sooty coagulants that come down are going to continue to come down. And in a cold, leaves us just one thing to work on, the acid. Work to counteract the acid, which produces... So, there you have it.
Say, Jim, who's that on your right there?
Ah, yes, I'd like to introduce you to one of the stars of the sports world, Wild, the famous relief pitcher for the Podunk Pirates. I'm sure you've all heard about him because he has an absolutely untarnished record this season. In all the games he pitched, he not only never got anyone out, he never even got one ball safely over the plate for a called strike. And yet, could it be possible that there's another side to his story? You see, then a short trip to the showers. I guess you can't blame old Wild Pitch for being sore. All those quick starts and short trips without warming up can ruin any pitcher's arm. So here's what this all adds up to. A cold engine suffers serious damage too. But now with new, this is one problem the more forget about. Well, let's see. We've got another demonstration here to prove how clean. Over here we have the new, we're going to put a measured amount in a jar to simulate the action which takes place in your, to show that this 3 times longer. In this jar, we have now, we're going to put 1 scoop of in. In other words, we're going to run both. All right. Now, the has enough body to hold these materials in suspension for a certain period. Long enough so that in the amount of time available to us for this demonstration, we wouldn't be able to see the resultant action. So, we merely cut both of them back. All we're doing here is just making an event happen faster. We want to be sure they get the same amount of... Now, the next step is to shake it up. Grandma, could you take care of that one over there? Now we're going to make sure that we've got all the stuff mixed up good. This typifies the material that comes down from the... It is the solids, the tetraethyl lead decomposition products. You see, what we're going to show here is how this new product holds in harmless dispersion because of its dramatic dispersant qualities. I think we start to see light coming through the jar that contains the conventional. You'll notice that you can't see it through. We'll let them stand a few moments longer. You can see the importance of this demonstration, and that means that when it is drained. With conventional, slowly to accumulate, slowly to build up, to restrict lines, to cause ring sticking, and it's our power robbers. This then is another dramatic proof of this truly revolutionary feature. Now let's take another look. This time we're going to put 2 more scoops. Now we're going to let them both stand for 5 minutes. See the light coming through the... And no light shows through the... Now to find out what we've got. We'll turn each jar over. Now comes the payoff. If we drain, this is what is left behind. I'll put that cap there. When we drain, the cap shows the aid clean. As you can see, this could easily represent the parts inside, so they'll continue to function as they were intended to function. Notice, too, that around the top of this jar, there's nothing. In a few moments of this demonstration, while these jars were sitting here, and it's not going to be knocked off, there's no deposit 3 times longer. You know, we may have fooled around a little here, but we're deadly serious when we say that the detection of makes it the best ever sold. Thank you.